Today we are going to work on solving equations. So this section we're going to call it 1 and 2-step equations. Two-step equations. So everything needs to be balanced. Whatever we do, we have to make sure that we maintain balance. So it's kind of like a scale that when we have one block over here, we must also have a one block over here. So if I'm going to take away a block, I must also take away a block from the other side in order to make it perfectly balanced. I'm going to add an extra one here and an extra one here, just so we kind of get that picture across. So basically, we have to remember our opposites. So if we are subtracting something, we must add it to move it across the equal sign. So I think the best way to kind of look at that is an example. So if I had r minus 3 is equal to 2, I would have to add this 3 to both sides. That maintains the balance. So we would be left with r is equal to 5. And we must always try to get the variable alone. I'm not going to say try, I'm going to say get the variable, isolate the variable. Variable. Let's do another example. Let's say if we were adding something. So let's do a different variable. Let's pick q plus 6 is equal to -1. Okay, so we got to subtract 6 from both sides. And that leaves us with q is equal to -7. It's the same thing as like adding a negative to both sides. Let's do a couple more examples. So I have a bad habit of picking the same set of variables. Let's say x plus 4 is equal to -6. Subtract 4 and subtract 4 from both sides of the equation. So that would leave us with x is equal to -10. What else? What else? Let's do some more. Let's go a minus 6 is equal to positive 13. Add 6 to both sides. And that would leave us with a is equal to 19. And one more just for posterity's sake. B plus 8 is equal to 2. Subtract 8, subtract 8. And b is equal to -6. I'm trying to make those look a little different. Okay, so that's about addition and subtraction. So this part will be multiplication and division. So multiplication and division are inverse processes of each other. So just like how addition and subtraction are, they kind of go back and forth. So for example, 3x is equal to 12. We need to get x by itself, and it's currently being multiplied by 3. So we have to divide by 3. And I like writing my division like this because it cancels there, and then I know that x is equal to 4. The other way that we can write this is you just simply write a little division sign up here. And it gets you to the same process. It just depends on how you like to look at it. So this brings balance to it. So let's do another example here. We're going to have 5x is equal to 10. Divide by 5 on both sides. X is equal to 2. 5 divided by 5 gives us 1. 10 divided by 5 gives us 2. Sometimes we will have it being dividing. So those are good multiplication examples. Let's say these as division examples. One of the ways that we're probably going to see it most often is that it's going to be for oh, those are all division examples. I meant to say the other way. One second. So these should be multiplication examples. So we will see these where it's b over 7 is equal to 2. So you will multiply by 7 to both sides because we need to get rid of this. And that will leave us with b is equal to 14. That's kind of like the other day when we talked about how we got to like one out or cancel things. So if this was being multiplied by 7 over 1, these guys cancel. We can cancel the numerator and the denominator, right? Let's do another one. So v over 4 is equal to negative 12. Multiply by 4 to both sides. This crosses out. b is equal to negative 48. And these are all one-step equations. So I'm going to pause it here. This will be one-step equations, and I'll make another video for two-step equations.